have an NMOS transistor here with a gate, a source and a drain. The input voltage is from the V gate to source. The output voltage is between the V drain to source, and the output current we're interested in is from the drain to source. So we actually have three things that we're interested in here: two voltages and a current. So if we want, we could generate the characteristics of this device and represent it as a surface in 3D space. So we could have, if you like, two inputs to the surface, which would be our V gate source and our V drain source, and we would have one output for the surface, which would be the current from the drain to source. Now, usually you'll see the characteristics represented in two-dimensional graphs, and they'll be split into the graph of the output voltage to the output current, or the graph of the input voltage to the output current. But we can represent them, as I said, as a three-dimensional surface. So if we were to change the values here for our gate voltage, you can see that we're going to increase or decrease the channel thickness here, and we're going to change the nature of the characteristic here, which is the output current against the output voltage. And again, we can move up and down this curve here by changing the drain voltage. And you can see us moving up along the curve, and we're in the linear region in pink, and we're in the saturation region in blue. So let's go ahead and we'll represent this in the 3D format. So this is the characteristics of our NMOS device represented as a surface in 3D space. You can see that we're going to have the output voltage VDS along this axis, we're going to have the input voltage VGS along this axis, and we're going to have the output current IDS along this axis. So the blue region here is going to be the cut-off region. The pink region here is going to be the linear region, and the yellow region here is going to be the saturation. Now you can see that if we were to adjust the angles here, so if we turn this round to this angle here, and we were to adjust that to 270 degrees, you can see that we're going to have the value of VDS along this axis and the value of IDS along this axis. And we're going to see the output characteristics, IDS against VDS, for different values of VGS. And you can see here we're going to have the linear region here in pink, and we're going to have the saturation region here in yellow. And we can adjust the resolution of this in order to get finer and finer detail. Now what we could do next is generate a surface for a PMOS device. We could then superimpose that surface on the surface for the NMOS, and at the point of intersection between those two surfaces we're going to get the transfer characteristics of a CMOS inverter. So we'll go ahead and we'll do that next.